In this video, we'll learn how to solve quadratic inequalities using two methods, the algebraic method and the graphical method. To help us with this, our textbook of reference will be the Additional Mathematics for West Africa, and this textbook is referenced in our bio using the Harvard referencing style. First, we must remind ourselves of the inequality symbols and what they mean before we get into the business of this video. Now, the first one we have on the list here is the greater than symbol. This sign here means greater than. And the second one is the greater than or equal to symbol. The third one is the less than symbol here. And the fourth one is the less than or equal to symbol. So now that we've gotten the symbols out of the way, we'll begin with the algebraic method using the number line. Alright, now let's begin with the algebraic method using the number line. First, we start with a quick reminder of what the number line looks like. Now we see here in this picture, this is a picture of a number line. We see that in the middle we have 0, which divides the number line into the positive side to the right and the negative to the right of 0, and the negative side to the left of 0. And we also see that as we move to the right, the numbers increase. Now this is from 0, increases to 1, to 2, and 3, and goes like that until infinity. And also from -3, it increases to -2, to -1, and 0, and it goes like that. And then we see that as we move to the left side, it decreases. Okay, we see from 3, it reduces to 2, from 2 decreases to 1, 1 decreases to 0, 0 decreases to -1, and goes on like that to infinity. So this is what the typical number line looks like. Right, so now that we've gotten this out of the way, let's move on to the next step where we'll be solving questions using the algebraic method and the number line. That's solving inequality questions with the number line. So I'll use these 4 examples to show you how you can use the algebraic method with the number line to solve quadratic inequalities. Now the first question that we have here is x squared plus 2x is less than or equal to 15. But to find the range of values of x for which this inequality is true. The second is x into x minus 3 greater than 10. The third one is 2x squared minus 5x plus 3 is less than 0. And the fourth one is x squared plus 5x minus 6 is less than 2 into x plus 2. So for all these questions, we are required to find the range of values of x for which these statements or these inequalities are true. Now let's see how we can do that. X squared plus 2x is less than or equal to 15. So let's see how we can solve this. So the first step is to ensure that the quadratic function is expressed in the form of ax squared plus bx plus c. So ensure the quadratic function is expressed in the form ax squared plus bx plus c. So how do we do this? We simply move 15 to this side, so it becomes x squared plus 2x minus 15 is less than or equal to 0. So now we have x squared plus 2x minus 15 expressed in this form ax squared plus bx plus c. Now the second step will be to find the zeros of the function Okay, now what are the zeros of a function? Zeros of a function f of x are the values of x that make f of x equal 0. Zeros of a function f of x are those values or value, if it's a linear function, of x that make f of x equal 0. Okay, so to find the zeros of this quadratic function, we simply equate x squared plus 2x minus 15 to 0, like this. Okay, now to find the zeros of this function, x squared plus 2x minus 15, we simply equate the quadratic function to 0 and then find the roots of the equation. Now, there are two ways to do this. We can do this either by way of factorization or by using the quadratic formula. To determine the zeros of the function, we find the roots of the equation by using 1, factorization, or 2, the quadratic formula. Now, for this example, we're going to be using these two methods so that I show you how to use both methods to find the roots of the equation. So let's begin with factorization method. Factorization method. Right. So how do we factorize this quadratic expression, x squared plus 2x minus 15? First thing you want to do is to multiply minus 15 with x squared here. Once you do that, you get minus 15x squared. Then you think of two separate expressions such that when you add them together, it gives you 2x here. And when you multiply them, it gives you minus 15x squared. Now those two expressions are 5x and minus 3x. You see that 5x times minus 3x equals minus 15x squared. And we also see that 5x plus minus 3x equals 5x minus 3x equals 2x. Okay, so now we come here to the quadratic function and we write this as x squared plus 5x minus 3x minus 15 equals 0. Now remember, 5x minus 3x gives 2x here, and 5x times minus 3x gives minus 15x squared, as we have shown here. Now, next thing to do will be to factorize. Now, we simply say x into x plus 5 minus 3 into x plus 5 equals 0. Now, in the process of factorization, what you have in the brackets must be the same. As we see here, we have x plus 5 in this bracket and x plus 5 in this other bracket, and they are the same. So if in the process of factorization, you see that you do not have the same elements in both brackets, then that tells you that you have made a mistake in your factorization and that you should go over your workings. So now these elements are the same, so we're good. So we'll simply take x here and minus 3 here as one factor. I will take x plus 5 here and x plus 5 here as the other factor of the quadratic expression. So to find the roots of the quadratic expression, we take this factor first and equate it to 0. So this gives us that x equals 3. And we take this other factor, x plus 5, and equate it to 0. So this gives us that x equals minus 5. So we have that the roots of the equation are 3 and minus 5. Now let's look at the second method of finding the roots of the quadratic equation, which is the quadratic formula. Let's see how we can use the quadratic formula. The quadratic formula is given as x equals minus b plus or minus the square root of b squared minus 4ac over 2a. So this formula is derived by completing the square on the standard quadratic equation ax squared plus bx plus c. It's derived by completing the square on the standard quadratic equation ax squared plus bx plus c. So for our equation x squared plus 2x minus 15 equals 0, to get the values of a and b and c to fix in the formula, we simply compare this equation and the standard equation. So this is ax squared plus bx plus c equals 0. Now comparing both of them, you see that a equals 1, which is the coefficient of x squared here. You see that a is the coefficient of x squared in the standard equation, and 1 is the coefficient of x squared in this equation here. So it means that a equals 1. And then b equals 2, because b is a coefficient of x here in the standard equation, and 2 is a coefficient of x here in the now quadratic equation of question. And then c equals minus 15. Okay. So now that we know what a is, we know what b is, and we know what c is, we simply put these values into our quadratic formula to get the roots of the equation. So let's do that. Remember, the formula is minus b plus or minus the square root of b squared minus 4ac over 2a. So x equals minus 2, because b is 2, plus or minus the square root of 2 squared minus 4 times a, which is 1, and times c, which is minus 15. Yeah? because it's sine, over 2 times a. Remember, a is 1, so we have it like this. So a equals equals minus 2 plus or minus the square root of 4, because 2 squared is 4, minus 4 times 1 times minus 15, that gives minus 60 over 2. So we have that x equals minus 2 plus or minus square root of 4 plus 60, because minus times minus here becomes plus, so this is plus 60 over 2, and x equals minus 2 plus or minus the square root of 64, because 4 plus 60 is 64 over 2, and x equals minus 2 plus or minus 8. The square root of 64 is 8 over 2, and x equals minus 2 plus 8 over 2, or minus 2 minus 8 over 2. Now x equals minus 2 plus 8 is 6 over 2. And second root of the equation, x equals minus 10, because minus 2 minus 8 is minus 10 over 2. So x equals 3, and x equals minus 5. So we see that we get 3 and minus 5 as the roots of the equation, just like we had in the factorization method, where we had 3 and minus 5 as the roots of the equation. Okay, so now we know the roots of the equation. So what's the next step? So now we know the zeros of the function to be 3 and minus 5. So how do we use the number line to solve the inequality? So this is where we use the number line to see how the function changes around 3 and 5 and minus 5, which are the zeros of the function. So let's draw the number line. Since we're only concerned with 3 and minus 5, we only need to show 3 and minus 5 on the number line. And if you like, you might show 0 to just illustrate the distinction between the positive and the negative sides of the number line. So let's draw the number line. And remember, we're to find the range of values of x for which x squared plus 2x minus 15 is less than or equal to 0, or x minus 3 into x plus 5 is less than or equal to 0. So how do we do this? Now let's draw our number line. So we have a line here. So number line. This is x, and then we can have our 0 here in the middle, and then we have 3, say somewhere here, and we have minus 5 somewhere here. So next we write out our factors. The first factor is x minus 3, and the other factor is x plus 5, and the product of those factors, which I'll call p, is x minus 3 into x plus 5. Okay, so remember, we have to determine the range of values for which the product is less than or equal to 0. That is, for which the product is negative or equal to 0, because any number that is less than 0 is a negative number. If it is greater than 0, it is a positive number. Okay, so starting from the left end of -5, which is this region here, where x is less than -5. We want to see if the function is positive or negative in this region. Positive means that it is greater than 0, and negative means that it is less than 0. So to the left of -5 here, we have numbers that are less than -5. We can have -6 here, we have -7, and so on. So what we do is that we just use one number in this region to test each of the factors to see whether it gives a positive or a negative number. Now remember, whatever is true for one number in this region is true for the other numbers. For example, if we say x is -6, and we put -6 in one of the factors x minus 3, you see that -6 minus 3 gives -9, right? Which is a negative number. If you say x is -7, see that -7 minus 3 gives -10, and that's a negative number. So you can say x is -100. If you see that -100 minus 3 gives -103, that's also a negative number. So it means that if one value of x in this region gives a negative number, all the other values of x will be a negative number. So you only need to test with one value of x in that space. Okay? So we're just going to use -6 in this case. And we really don't need to write it. It's just something that you can do in your head. So I'm going to erase this. Okay, so testing with -6, we know that x minus 3 is negative. And if we use -6 again with x plus 5, that's -6 plus 5. This is also equal to 5 minus 6, which is -1. You see that this is a negative number as well. So write a minus sign here. Okay, so now you see the process. And remember to find the product of the factors. Now, if this factor gives a negative number and this factor gives a negative number, remember the product of two negative numbers or elements is a positive one, because minus times minus is plus. So we say minus times minus here gives plus, gives a positive number. Okay, so we say that the product here, since it is positive, is greater than 0. Okay, now moving on to 5. When x is equal to -5 or -5. Now, we know that when x is -5, x plus 5 is 0, right? Because it's one of the roots of the equation. So meaning that the product will automatically be 0. So we know that product is 0 here. You really don't need to find what x minus 3 will be when x is -5, because if 1 is 0, it means that regardless of what x minus 3 is, the product will be 0. Remember, the main concern here is the product. So the product here will be 0, and this will be 0. Okay, so this line just shows that this is 0 when x is equal to -5. So now we'll move to the right of -5, where x is between -5 and 3. So here we know that x is greater than -5, but less than 3. So write this as -5 is less than x, is less than 3. Okay, so that's the region here, between -5 and 3. So now we want to determine whether the product will be positive or negative in this region where x is greater than 5 and less than 3. Now, remember, we can use any value in this region to test. So we're just going to use 0 to test each of the factors. Now we see that 0 minus 3 gives a negative number, which is minus 3. And we see that when x is 0, 0 plus 5 gives a positive number, which is 5. So we see that this is a plus sign here. So minus times plus gives minus. So we write minus here. And since the product is negative, we know that the product here will be less than 0. Now moving to the right, where it is exactly 3, where x is 3, we know that x minus 3 will be 0 because it is one of the roots of the equation. So along 0, we have that our product will be equal to 0. Now moving on to where x is greater than 3, that's to the right of 3. When x is greater than 3, remember you can use any number in this region, so let's use 4. We see that 4 minus 3 is 1, which is a positive number, so we write plus here. And 4, because we're using 4, 4 plus 5 is 9, which is a positive number. So we'll just write plus here. And then we know that plus times plus is plus. So the product will be positive. And since it's a positive number, we know that p is greater than 0. Okay, so we now see that this is how the product or the quadratic function behaves around, this is how the quadratic function behaves around the roots of the equation minus 5 and 3. So now remember, we're concerned with the region or the regions where the product is less than or equal to 0. Now we see that the product is only less than 0 here, where x is between minus 5 and 3. And of course it's equal to 0 at minus 5 and 3. So the solution to this inequality will simply be minus 5 less than or equal to, remember, we're also finding where it is equal to 0, so we have to include the equal to sign here in the inequality. So it's minus 5 less than or equal to x, which is less than or equal to 3. So this is the solution to the inequality. So the range of values of x for which, so you can state the solution like this. Range of values of x for which x squared plus 2x is less than or equal to 15 is minus 5 less than or equal to x less than or equal to 3. So this is the solution. Now let's move on to other examples so that we can further see how we can use the algebraic method to solve quadratic inequalities. Okay, so this is question 2, and it is x into x minus 3 greater than 10. Okay, so we have to find the range of values of x for which this statement is correct, or we're just going to solve this inequality. So remember, the first thing we want to do is to express this in the standard form, ax squared plus bx plus c. So we do this by expanding the brackets. So this is x squared, which is x times x here, minus 3x, which is x times minus 3, greater than 10. We move 10 to this side, becomes x squared minus 3x minus 10 is greater than 0. Okay, so after this, the next step will be to find the zeros of the function. So I'm going to say this equals 0, we need to use the factorization method here. But remember, you can use the quadratic formula if you wish to. But here, I'm going to use the factorization method. So this is minus 5x plus 2x minus 10 equals 0. It's x minus 5. 6 plus 2 to x minus 5 equals 0. So this is x minus 5 to x plus 2 equals 0. X minus 5 equals 0. X equals 5. X plus 2 equals 0. And x equals minus 2. So we have that the zeros of the function are 5 and negative 2. Now that we've gotten the zeros of the function, or the roots of the equation, the next thing we want to do is to see how the quadratic function behaves around the zeros of the function, so that we can find the values of x for which this expression, x squared minus 3x minus 10, is greater than 0. Alright, so this is our number line. And remember, this is the quadratic inequality, minus 10 greater than 0, or we could write it as this, as a product of its factors, greater than 0. So we have x here, and of course we have 0 in the middle, then we have 5, let's say somewhere here, we have minus 2 here. We have the first factor, x minus 5, and x plus 2. Have this, the product here. Alright, so let's begin. So in this region to the left of minus 2, we have that x is less than minus 2. Here between minus 2 and 5, we have that minus 2 is less than x, and x is less than 5. And here to the right of 5, we have that x is greater than 5. So let's see how the function behaves around the roots of the equation, or the zeros of the function. Now, for where x is less than minus 2, we want to see if the function is positive or negative. That is, if it is greater than 0, which means that it's positive, or if it's less than 0, which means that it's negative. So we're going to use any value in this region where x is less than minus 2. So if whatever is true for one value of x in this space where x is less than minus 2 will be true for all the other values. Now I'm just going to choose a random number in this space. Let's say minus 4. Right? Of course, you know that after minus 2 you have minus 3, but I'm just choosing to use a random number, minus 4, to test it. Okay, so if I say x is minus 4, this factor here, x minus 5, will be minus 9, because minus 4 minus 5 equals minus 9. So that means that it's negative, right? So I'm just going to write that it's negative here. When x is minus 4, this will also be negative. And minus times minus is plus, just like we did in the previous example. So we have that the product is greater than 0 for where x is, for the region where x is less than minus 2. Okay, so I'm just going to erase this. This was going to erase this minus 4 here. This was just for the purpose of the illustration. So where x is equal to minus 2, we have that this factor here will be 0. And if this factor here is 0, the product will be 0 as well. So I'm just going to draw a line. I'm going to say that this is 0. I'm going to say that this is 0. So the product is equal to 0. Now, between minus 2 and 5, remember you can choose any random number between minus 2 and 5 to test. So I'm just going to use 0. So if x is 0, of course, the x minus 5 will be minus 5, that's a negative number. If x is 0, x plus 2 will be 2, and that's a positive number. And minus times plus is minus. So for this region where minus 2 is less than x and x is greater than 5, we say that the product is less than 0 because it's negative. Now, when x is equal to 5, this will be 0, of course. So this is 0 here, all the way down here. We have that the product is 0. Product is equal to 0 here. And then where x is greater than 5, remember, choose any random number. So if we choose, say, 7 minus 5 is 2, so we have positive here. 7 plus 2 is 9, so we have a positive here. And plus times plus is plus, so we have this as positive. So we say that the product is greater than 0 when x is greater than 5. Alright, so now remember the inequality says we should find the range of values of x for which the product is greater than 0. That is here and here. P is greater than 0 here. Of course, P is the product, right? P is greater than 0 here, P is greater than 0 here. So we have that solution to the inequality is x is less than minus 2 or x is greater than 5. So this is the answer. Now let's look at the next example. Here it says solve 2x squared minus 5x plus 3 less than 0. Okay, so find the zeros of the function. Simply equates the quadratic function to 0. Okay, so equating this to 0, we have that 2x squared minus 3x minus 2x plus 3 equals 0. Okay, so this is x into 2x minus 3 minus 1 into 2x minus 3 equals 0. This equals 0. Minus 1 equals 0, x equals 1. So x equals 3, x equals 3 over 2. So we have that the roots or zeros of the function are 1 and 3 over 2. So now we want to find the range of values for which this expression, or expressing it as a product of its factors x minus 1 and 2x minus 3 is less than 0. Okay, so let's move to our number line. So this is x, have 0 here, and we know that in this case both roots of the equation are positive, so they're all going to be on this side of the number line. That is 1 and 1.5, which is also 3 over 2. So we have that in this space here, this whole space here, have that x is less than 1. Here we have that as between 1 and 1.5. We have that 1 is less than x, less than 1.5. And after 1.5, to the right of 1.5, we have that x is greater than 1.5. Okay? And of course, we have the factors here. Of x minus 1 because this is the product. So let's see how the function behaves around the roots of the equation. Okay, so where x is less than 1, we have that this factor 2x minus 3 is negative, so we write negative here. Where x is less than 1, we have that this is negative, and minus times minus is plus, so write that this is plus here. So when x is less than 1 means that the product is greater than 0, right? So when x is 1, this of course, x minus 1 will be 0, so the product will be 0, so we have that product is equal to 0 here. And then in between 1 and 1.5, now remember, you can think of any number between 1 and 1.5. So I'm just gonna say maybe 1.4. Okay. So if you put 1.4 into this factor here, you find that you have a negative number. So this would be negative here. And then this, if you put 1.4 into this factor here, you have a positive number. So this is going to be positive here. And minus times plus is minus, so we have minus here. So for this region where 1 is less than x, or x is greater than 1, and less than 1.5, you have that the product is less than 0. Now for 1.5, okay, so I'm just going to erase this to allow for more space so that it looks neater. I'm just going to put it here. Okay, just so there's more space. Okay. Now, this will be 0 here, of course. And then the product, of course, will be 0. That's equal to 0. Now, where x is greater than 1.5, of course, remember you can choose any random number. I could choose 1.6. Now, if I put 1.6 in this factor here, it's going to be positive. If I put it here, it's going to be positive as well. So plus times plus is plus. So we have that the product is greater than 0 for where x is greater than 1.5. Now remember, the inequality we're solving is 2x minus 3 into x minus 1 is less than 0. So we're looking for the range of values of x for which the product is less than 0. So we have it here. This is where the product is less than 0. So we have that the solution to the inequality, or the range of values of x for which this inequality, or this quadratic function, I beg your pardon, the range of values of x for which this quadratic function is less than 0 is 1, it's less than x, it's less than 1.5. So this is the solution. So the next example is solve x squared plus 5x minus 6 is less than 2 into x plus 2. Now, the first thing we want to do is to rewrite this in the standard quadratic form of ax squared plus bx plus c. So we say x squared plus 5x minus 6 is less than 2x plus 4. This is plus. So we have that this is x squared plus 5x minus 6 minus 2x minus 4 is less than 0. We have that this is x squared plus 5x minus 2x minus 6 minus 4 is less than 0. So this is x squared plus 3x minus 10 is less than 0. Now we need to find the zeros of the function of of this quadratic function x squared plus 3x minus 10, zeros of the function. So we simply equate x squared plus 3x minus 10 to 0 and find the roots of the equation. So I'm going to use factorization method here. So this is x squared plus 5x minus 2x minus 10 equals 0. This is x into x plus 5 minus 2 into x plus 5 equals 0. And we have that x minus 2 is one factor and x plus 5 is the other factor. So x minus 2 equals 0. We have that x equals 2 as one root of the equation, and x plus 5 equals 0. We have that x equals minus 5 as the other root of the equation. So now we have that the zeros of the function are 2 minus 5. Now let's go to our number line to see the range of values of x for which x squared plus 3x minus 10 is less than 0. Alright, so we have our number line here with 0 in the middle. Now let's find the range of values of x for which x minus 2 into x plus 5, expressing the quadratic function as a product of its factors, is less than 0. Now we have that one factor is x minus 2. We have the other factor to be x plus 5. And then we have the product, of course, to be x minus 2 into x plus 5. And then put the zeros of the function here. The zeros of the function are x equals 2 and x equals minus 5. So we can have 2 somewhere here. We can have minus 5 somewhere here. Alright, so in this region, we have that x is less than minus 5. Here, between minus 5 and 2, we have that minus 5 is less than x is less than 2. And here to the right of 2, we have that x is greater than 2. So when x is less than minus 5, we have that this factor will be negative. When x is less than minus 5, we have that this factor will be negative. Therefore, the product, which is minus times minus, is plus. So we have plus here, meaning that the product will be greater than 0, because all positive numbers are greater than 0. And then when it is exactly minus 5, we have that x plus 5 will be 0, and of course the product will be 0. So we have that product here equals 0. And then in between minus 5 and 2, we have that x minus 2 will be a negative number, and x plus 5 will be positive. Minus times plus is minus. So we have that the product here will be less than 0. Now when it is 2, we have that this is 0, going all the way here. This will be 0 as well. We'll have that the product will be equal to 0. Now when x is greater than 2, we have that this will be positive. This factor x minus 2 will be positive, and the factor x plus 5 will be positive as well. Therefore, the product will be positive because plus times plus is plus. So this product here will be greater than 0. Now, the inequality says that we should find the range of values of x for which the quadratic function is less than 0 here. Alright, so we see that the product is less than 0 here. So the solution to inequality is -5 is less than x is less than 0. This is the answer. Let's write this clearly. And yeah. Alright, so this is the solution to the inequality. Now we move to the next phase, which is the graphical method. We're going to learn how to use graphical method to solve inequalities, quadratic inequalities. Alright, so now we move to the graphical method. Now in this graphical method, in order to solve the inequality with the graphical method, what we need to do will be to graph the quadratic function on the x-axis using the zeros of the function or the roots of the quadratic equation. Now before we move into this, let's just do a quick reminder of what the Cartesian plane looks like. Now this is a typical Cartesian plane where we have the y-axis, which is the y is usually the dependent variable here, and then we have the x-axis here, which is the horizontal axis, the y is the vertical axis, y is the dependent variable, and then we have the x-axis, which is the horizontal axis, and the x is the independent variable. So above the x-axis, we have that y is positive because you have positive numbers here, 1, 2, 3. So above the x-axis, the values of y are positive. Now below the x-axis, the values of y are negative, as we have here, -1, -2, and -3. Now we understand the importance of this as we proceed further. And also with the x-axis to the right of the origin here, you have positive values of x, and then to the left of the origin here, you have negative values of x. Okay, so this basic things, these fundamental things will be very important for us to understand how to use the graphical method to solve quadratic inequalities. Now let's move to the next phase where we'll be learning how to sketch quadratic inequalities on the x-axis of the Cartesian plane. Now, the first thing we need to learn is minimum and maximum quadratic functions. Now, for a typical quadratic function, f of x or y equals x squared, ax squared plus bx plus c, we have the following rules. If a, that is the coefficient of x squared here, is greater than 0, we have a minimum value. So the quadratic function curve will dip like this or will look like this, right? But if a is less than 0, it means that we have a maximum value. So the graph will curve upwards like this. Okay, so if it's a minimum value where a is greater than 0, the curve dips downwards. If it's a maximum value where a is less than 0, the curve goes upwards. Okay, that's one rule. So now let's see other things that we need to learn with the graphical method for solving quadratic inequalities. Now, in the case where we have complex roots, where b squared is less than 4ac, it would mean that in the quadratic formula, which is given by x equals minus b plus or minus b squared minus 4ac over 2a, it would mean that the square root of b squared minus 4ac will be non-existent because b squared being less than 4ac would mean that b squared minus 4ac, which is usually represented as d, called the discriminant. Alright, so in the course of the video, we'll learn why d is called the discriminant. Discriminant spelled like this. We'll learn why b squared minus 4ac is called the discriminant d. Alright, so in a situation where b squared is less than 4ac, we would have that b squared minus 4ac, or d, is a negative number. And of course, the square root of a negative number is non-existent in actuality. So we usually represent it with an imaginary number called I. And in such a situation, we have complex roots. Now looking at the curve of the x-axis, in such a situation, the curve does not touch the x-axis, and neither does it cut the x-axis. It's just above the x-axis, in this case where a is greater than 0, because we have a minimum value, so it dips downwards, okay? And in this situation, we have that for all values of x, ax squared plus bx plus c is greater than 0, okay? And then when b squared is less than 4ac, again in a situation where we have complex roots and a is less than 0, it means that we have a maximum value. And then for all values of x, it means that a squared plus bx plus c is less than 0, because this region below the x-axis is the region in the Cartesian plane where y is negative, that's below the x-axis. And this region in the Cartesian plane above the x-axis is where y is positive, as we showed in this diagram here. Below the x-axis you have negative values. Below the x-axis you have negative values of y, and above the x-axis you have positive values of y, right? So in this case, above the x-axis you have all the values of ax squared plus bx plus c to be greater than 0, because y equals this ax squared plus bx plus c. So you have all the values of y to be greater than 0 in this case. So they're positive. And then in this case, where we have a maximum value, we have that all the values of y are less than 0 and they're negative. Okay, now in the case where we have real and equal roots, in such a case, b squared will be equal to 4ac, and then d will be 0, that's b squared minus 4ac will be 0. So the roots of the quadratic equation will be the same. And where we have that a is greater than 0, meaning that we have a minimum value, we have that all values of ax squared plus bx plus c will be greater than or equal to 0, right, where it touches the x-axis. And then in the case where we have b squared is equal to 4ac, and then a is less than 0, giving us a maximum value, we have that ax squared plus bx plus c is less than 0 because it is beneath the x-axis. So it is less than 0 or equal to 0 because it touches the x-axis here. And the third one, where we have b squared, that's where we have real and different roots, where b squared is greater than 4ac and a is greater than 0, so we have a minimum value. We see that the curve dips downwards here and then cuts the x-axis at two unique points because we have different roots, and we call them alpha and beta. So we can have alpha here and beta here. Now for the region below the x-axis, we have negative values of y, just like we saw in the Cartesian plane. And for the regions above the x-axis, we have positive values of y, as we saw in the Cartesian plane. So when x is less than alpha, that's to this region here, assuming that here is alpha, we have that ax squared plus bx plus c is greater than 0. When x is less than beta, assuming that we have beta here, in this region, we have that ax squared plus bx plus c is greater than 0, meaning that it's positive. And right here in the middle between alpha and beta, we have a negative value because the curve is beneath the x-axis, and we have that ax squared plus bx plus c is less than 0. The same here, where b squared is greater than 4ac, we have real and different roots, right? But then here, a is less than 0, so the curve goes upwards like this. And then where the curve is below the x-axis, you have that ax squared plus bx plus c is less than 0, meaning that it's negative. That's here and here. And where it is above the x-axis, that's this region here, we have that ax squared plus bx plus c is greater than 0. When we start to do some of the examples, you'll see how all of this apply, and it will start to make sense. Now, D discriminates quadratic functions depending on the type of roots they have. It distinguishes the quadratic function depending on the type of roots they have. Now, we see that in this case, where we have complex roots where D is less than 0, the curve does not touch or meet the x-axis. It's above or below the x-axis. We see here where we have real and equal roots where D is equal to 0, that the curve just touches the x-axis. That's a distinguishing feature. We see another distinguishing feature where D is greater than 0, where we have real and different roots, that the curve cuts the x-axis at 2 distinct points. So we also see here where we have real and different roots, where D is greater than 0, we see that the curve cuts the x-axis at 2 distinct points, which we have labeled as alpha and beta. So we see that for all the different kinds of roots, real and different roots, real and equal roots, and complex roots, that D distinguishes the curves across all these types of roots. So it discriminates the curve across the various types of roots. That's why it's called the discriminant. So let's get started with some of the examples and see how we can sketch quadratic functions on the x-axis and how we can solve inequalities using the graphical method. So the first example here is to solve the inequality 3x squared plus 5x is less than 2. Now let's see how we can do this on our Microsoft whiteboard. So this is the first example, and we're to solve this using the graphical method. So the first step is to write it in the standard quadratic form. That is 3x squared plus 5x minus 2 is less than 0. Now, the second step will be to sketch the function on the x-axis. So this is the second step. So how do we do this? Now remember our rules. If a is greater than 0, we have a minimum value. So the curve dips downwards and is going to look like this. But if a is less than 0, we have a maximum value. So the curve goes like this. Now in this case, we see that a equals 3, which is greater than 0. This implies that we have a minimum value. So the curve will look like this on the x-axis. Now, next thing we want to do is to find the zeros of the function to see where the curve intersects or cuts the x-axis. Now, how do we find the zeros of the function? So to find the zeros of the function, you simply equate the quadratic function to 0 and find the roots of the equation. Now we can do this by two methods as we had shown earlier, the factorization method and the quadratic formula. So I'm just going to use the factorization method here. Now this is 3x squared plus 6x minus x minus 2 equals 0. This is 3x expanding into x plus 2 minus 1 into x plus 2 equals 0. So we have factors as 3x minus 1 and x plus 2 equals 0. Therefore, the zeros of the function will be 3x minus 1 equals 0, so x equals 1 over 3. That's 1. And x plus 2 equals 0, so x equals minus 2. And that's the second one. So we have the zeros of the function as 1 over 3 and minus 2. So now to sketching the curve on the x-axis. So now we have the zeros of the function to be minus 2 and 1 over 3. So we're going to sketch the function 3x squared plus 5x minus 2. And we're going to find the region where 3x squared plus 5x minus 2 is less than 0. And we see the range of values of x for which this function is less than 0. Now to sketch the function, let's draw our x-axis. So this is the x-axis. Remember, it's a minimum. It's a minimum value. So it's going to look like this. It's going to dip downwards. So we can have something like this, right? And then say we have minus 2 here. We have 1 over 3 here. Remember, it's a sketch, not accurate. It's just to show us the range of values for where the function is positive and where the function is negative. Where it's positive, we know that it's greater than 0. Where it's negative, we know that it's less than 0. Now, in this space where x is less than minus 2, we have that the function is positive because it's above the x-axis. Remember, from our Cartesian plane, all values of y above the x-axis are positive. Now here, in between minus 2 and 1 over 3, that is where minus 2 is less than x, is less than 1 over 3. We have that the function is negative because it's below the x-axis, right? And then we have here, to the right of 1 over 3, that is where x is greater than 1 over 3, we have that the function is positive, okay, which means that it is greater than 0. So our concern here is to find the range of values of x for which the function is less than 0, that is, for which the function is negative. That's what we have here. So the range of values of x for which the function is negative, which is the solution to the inequality, will be minus 2 is less than x is less than 1 over 3, as we have seen here. So this is the answer to our inequality. Very simple. Now let's see another example. So the second example here is 3x squared plus 11x is less than 4. Now let's move over to a Microsoft Whiteboard to see how we can solve this pretty much the same way as we solved the first question. 3x squared plus 11x is less than 4. So we're going to solve. Just going to write the instruction. Solve the inequality, or if we state it this way, find the range of values of x for which the statement is true. Alright, so remember, first write out the inequality in the standard quadratic notation. So first you want to write out the inequality in the standard quadratic notation as 3x squared plus 11x minus 4 less than 0. So 3x squared plus 11x minus 4 is in the standard quadratic notation. And the second is where we sketch the curve. So first we want to determine if it's a minimum or maximum curve. Alright, and remember the rule: if a is greater than 0, we have a minimum. If a is less than 0, we have a maximum. In this case, a equals 3, which is greater than 0, so we have a minimum. Alright, now the next thing to do will be to find the zeros of the function. So to find the zeros of the function, we simply equate the quadratic function to 0. To factorize this, I'm going to use the factorization method here. You can choose to use the quadratic formula or the factorization method. It's really up to you. But I'm going to use the factorization method here. So I'm going to say this is 3x squared plus 12x minus x minus 4 equals 0. So this is 3x into x plus 4. This is minus 1 into x plus 4 equals 0. So the factors are 3x minus 1 and x plus 4 equals 0. So 3x minus 1 equals 0, x equals 1 over 3. This is 0. I'm going to write this clearly. Right. And x plus 4 equals 0, so x equals negative or minus 4. Okay, so we have that the zeros of the function are 1 over 3 and minus 4. Now we sketch the function on the x-axis. So the zeros of the function, remember, are 1 over 3 and minus 4. And we're to determine the range of values of x for which 3x squared plus 11x minus 4 is less than 0. And we have that this is a minimum curve. So we have this information to sketch the curve on the x-axis. So this is the x-axis here. I have a minimum curve. So if we have minus 4 here, have 1 over 3 here, have this positive because it's above the x-axis, positive because it's above the x-axis, and here negative because it's below the x-axis. Now in this region, this is where x is less than minus 4, so the left of minus 4, just like we have in the number line. and in between minus 4 and 1 over 3, we have that minus 4 is less than x, and x is less than 1 over 3. And to the right of 1 over 3, we have that x is greater than 1 over 3. Okay, so remember, we have to find the range of values of x for which the quadratic function is less than 0, that is, for which it is negative. Now, we can see that it is negative in this region where x is less than 1 over 3 and greater than minus 4. As a combined inequality, we have it in this form. So the solution will be minus 4 is less than x is less than 1 over 3. This is the solution. Now, the next example is 5 plus 10x minus x squared is greater than or equal to 3x minus 13. So what's to solve this inequality? Now, the first step is to write this in the standard notation. First step. So I'm going to say this is 5 plus 10x minus x squared minus 3x plus 13 is greater than or equal to 0. Collecting like terms, this will be minus x squared plus 10x minus 3x plus 5 plus 13 greater than or equal to 0. So I just grouped the like terms, collected them together. So now we have minus x squared plus 7x plus 18 is greater than or equal to 0. Now the second step will be sketching the quadratic function. Now we have to determine whether we have a minimum or maximum curve. Since a is equal to minus 1 and minus 1 is less than 0, we have a maximum value, meaning that the curve will look like this. Alright, so now we determine the zeros of the function so that we see where the curve intersects or meets the x-axis. So this is minus x squared plus 7x plus 18 equals 0. Okay, so I'm just going to use the quadratic formula here. Remember, you can also use the factorization method, whichever one you like. I'm just going to use the quadratic formula here because I have used the factorization method in the first example, so I'm going to use the quadratic formula here. Now, from the quadratic function, we have that a equals minus 1, we have that b equals 7, and c equals 18. So I'm just going to put these values in the formula. It's going to be minus 7 plus or minus root 7 squared minus 4 times minus 1 times 18 over 2 times minus 1. So we have that x equals minus 7 plus or minus square root of 49 minus 72 over minus 2. So we have that x equals minus 7 plus or minus the square root of 49 plus 72 over minus 2. So we have that x equals minus 7 plus or minus the square root of 121 over minus 2. So we have that x equals minus 7 plus 11 over minus 2, which is equal to 4 over minus 2, which is equal to minus 2. And we have that x equals minus 7 minus 11 over minus 2, and this is equal to minus 18 over minus 2, which is equal to 9. So we have that the roots of the equation are minus 2 and 9, or the zeros of the function are minus 2 and 9. So now let's move to sketching the curve on the x-axis. So to sketch the curve, we're going to write out all the information that we have. The zeros of the function x equals minus 2 and x equals 9. And the function which we have rewritten and the inequality which we have rewritten in the standard quadratic notation as minus x squared plus 7x plus 18 greater than or equal to 0. And we know, of course, that it's a maximum curve, or it has a maximum value. So now we sketch the quadratic function on the x-axis. So since it's a maximum curve, it's going to go like this. Remember, this is just a sketch. So we have here to be minus 2, and say here is 9. Remember, for the areas below the x-axis, the values of y, which is the dependent variable, will be negative. And for areas above the x-axis, the values of y, or the values of minus x squared plus 7x plus 18 will be positive, right? Okay, so remember, we have to determine the range of values of x for which the function is greater than or equal to 0. So to the left of minus 2, we have that x is less than minus 2, which is this point here. In between minus 2 and 9, that's where minus 2 is less than x, less than 9. We have that x is positive. And remember, it is also equal to 0 at minus 2 and 9, right? And then where x is greater than 9, we have that the function is negative. So the solution to our inequality will be minus 2 is less than or equal to x. It's less than or equal to 9. So we introduce the equality sign here because we have an inequality sign. We have an equality sign in the inequality question, meaning that we're also looking for the values of x for which the function is greater than 0 and also equal to 0. So that's what we have here as the solution. Alright, so we have successfully demonstrated how to solve quadratic inequalities using the graphical method. We used 3 examples where we saw in the first 2 we had a minimum value, and then in the last example we had a maximum value. And then we looked at how the curve behaved around the zeros of the function. The areas where they were negative, that's where we had that the function was less than 0. And then the areas where they were positive, we had the function was greater than 0. Alright guys, so that will do it for our video on solving quadratic inequalities using the algebraic method and the number line, and then using the graphical method with a sketch of the curve on the x-axis. So I hope that you guys learned a lot from this video. If you have any questions or any comments or suggestions, please leave them in the comments. And if you found this video really valuable, please like and subscribe, as this will encourage me to post more videos. Thanks for watching.